All right. Any questions? You had a question.
Yeah, yes.
Can you?
Yeah,
No, no one else going to be able to see this.
no. Just if I'm passing for find each, shall I pass parameter like this or
No,
it
find each takes as a parameter a block.
just a block, no
Just a
other
block, no other parameters.
If I want to say add register accessor,
Yeah.
colon, and I give suppose name, but instead of name I actually want the value that is in the name there. So how do I substitute this variable value?
I'm not sure whether accessor is willing to take a string.
Okay.
It might be, so you should try that out. Because we always give it a symbol, but I think it might be perfectly happy with the string. So try if it takes a string. You can just try that on the command line. And if so, then your life is easy, right? You have the string. And if not, there's got to be some way of turning a string into a symbol.
So the first question is still kind of bizarre, Professor. I mean, we did understand creating the instance variables for the class, but that is not making sense if we have two objects of the city class and because both the objects are having the same values now.
All right. So let me draw a picture. If this thing crashed on me all morning, so I'm going to do this in a different way. So, so there's this. We're going to do city, right? So we have the city class. So that's an object. And then we would have a couple of instances of type city. And so the complexity is what data do these things have? So in and city, of course, derives from CSV base. No, I don't know if that's, or not, I can't erase it here. Okay. So a city is going to have, in some way, we need to store the attributes. Do we store the attributes in a map or in two parallel arrays?
Two parallel arrays.
So you want two parallel arrays, okay? Even though a map kind of sounds more sophisticated. I guess the reason is that you already had the first array because it came for free. All right, so in here we have then the names of the fields. Field names. And this one also has a different array of, well, the field names are going to be the same.
Oh, so the problem is.
And the field values are going to be different. All right, so the values, because they're going to be different for every object, they have to be stored per object. It's a single array, but they definitely have to be stored per object. And now actually this thing, you have two choices. You can put this array into each city object, or you can say I'm just going to, it's going to be inherited from CSV base. Because it's generic. A city doesn't look any different from, now I can make good use of this, from a country. It also needs an array of field values. But that's just an array.
But that still has a different
Right.
attributes
So this thing here, I put those into the CSV base object. So that means that I had to make sure that the constructor for a CSV base, the initialize for CSV base, calls adder accessor to make that thing. So then that way, when you make a CSV-based object, by the regular old constructor mechanism, there's no magic, there's nothing special or different here. So the regular constructor, the way that all other constructors always work, they can make, in Ruby, they can make
So So add to accessor basically creates the getter and setter methods, but inside the initialize method you actually set the initial values to those, right?
I think
So
you may have a good point there. Okay, let's so what you're saying is I need to do two things. I need to call the adder accessor, and then what I should also do is inside the constructor I should attach a blank array, so
right.
that it's not null. That sounds fair.
That's actually not null because when you're reading the when you're calling city class, you're reading the city.csv file, so your field values
Oh.
array will be initialized to name and country.
No. I'm not. We're not talking about these ones at all right now. We're talking about the values.
But the problem is with the
So
field
so
names.
but no, actually. So when are the values initialized?
When you say dot new.
Oh, because are we doing this the cheap way that we're just reading the first one?
Yes.
Yes. All right.
Oh no, actually values we are setting it from the console. We are not reading the first line of the CSV file actually.
Well, in that case,
That's for the name and country.
okay. In that case, what I what I would do is I would rig the constructor so that it makes an array of nulls. Because otherwise you're going to have a tough time with the lookup. So when you make the method missing, you're going to look at the you're going to try to find the thing inside here, and then in the parallel array thing, you're going to see what's in there. Well, at the beginning, it's going to be null. But if you don't even have that array, then you'd have to code up a special case. You could create it on demand and code up a special case. But I think the straightforward thing would be that when you construct when you construct any CSV object, you figure out what is the length of the field names in the corresponding class, and you create an array of this many nulls, and that's your field values.
No, professor. I mean, still, you are saying so the initialize method define underscore initialize in CSV this class.
Yes.
I'm not assigning any field values to that
Well,
for the at the rate field names.
what I'm saying is you should make an empty array. That's your field values. Yeah, you should set it in the initialize method.
Okay, then where am I assigning actual name and country to field names?
Like one of you guys just pointed out that happens just in the tester code. So we're being totally cheap. We're not even reading apparently the first line.
No, we are reading the first line.
No, the second line. The second line. We're not reading any data from the CSV.
Yes.
Okay, so we're just being totally lazy here. That's okay, because I can test it just as well. So all you're doing is you're reading the first line. You're not reading any of the other lines.
Right.
So the only way to construct an object is to say city.new,
Right.
which when you call city.new, city.initialize happens. City.initialize calls csv.initialize, which makes a per object instance of this values array. So then there's the independent question. Let me know when you're ready for the answer to that question. What to do with the names? Because the names are totally different.
So that is the whole problem.
All right. So now, what do we do with the names? The names can be done per subclass. So city.class can have names. Country.class can have names, but you can't put it into CSV base. So you have to be very careful to say class dot whatever the magic thing is to make an.
So that's what I do. When I say class dot, then I no longer have that problem of names getting
Right.
Overwritten.
Right.
But the problem is when I create the second object of city,
Yes.
it actually goes ahead and mutates the original values of my first city object.
I think so. I need to see the code. Okay, put the code on Piazza and I'll look at it.
I emailed you through that.
Yeah, put the code on Piazza and I'll double check. Yeah, don't worry about like putting code on Piazza. There's so much bad code on Piazza right now that it would take a monumental effort by anyone to try to harvest any good ideas from it. So it's probably easier to rethink through it yourself. So I'm not concerned about seeing lots of code there.
So when you say class dot instance variables, the instance variables are associated with the class, right, Professor?
Yes. So each class has an object. That's the object that I have here. So what I'm trying to say is that the field names here they should be up here.
And how do I associate field values to each object instead of to the class?
Because you just make this is an array of whatnots.
Right.
And so inside your method missing, you're just going to have to fish out this array and then
Right.
access the ith slot.
So right now what happens is my values is also a part of the class.
That won't work because then they'll override each other.
Yeah,
Right.
probably.
That's what I'm saying. You have to treat them separately.
Okay.
So it doesn't hurt to have the names multiplied. That's just wasteful, but it's not going to be wrong. But if you have the values shared, that will not work.
Right, right.
Yeah.
Okay.
And so you have to, it's very fussy about, as it should be, about the way you declare these things. And so I think that the fact that you have to think hard about that, that's not a problem. The only problem in Ruby is that the mechanism for doing one or the other is not very symmetrical. That the way that you make a class object is very different from the way that you do anything in an instance. The syntax is completely ad hoc. Because you can see that on Tuesday, he named the methods one way, and on Thursday, he named this completely related method just differently, and that's the struggle that you have. At least that compounds the struggle. But you have to get the basic stuff straight. So draw these diagrams and ask yourself exactly where the stuff is. And so the way you draw the diagrams is that you need to separate the objects versus the classes, and in the objects, you need to figure out there is a superclass portion. That's what each object always inherits from a superclass, and then there's the proper portion of what the class has itself, or what the object has itself. And you need to ask yourself, where does what is what? You need to come up with a cogent layout that makes the whole thing possible, and then once you have the layout, then you can write the code, and it's all going to work out. If you write the code first and then try to beat it into submission, you don't have that kind of time. Yeah?
Do we need to define a class method inside a class method? Like define for each under inside has many? Or are they
No.
separate?
No, you don't need to do that. When the only reason that you would need to define a method, that you would need to kind of synthesize a method, if you look at what we did with initialize in the lab, that was a method that kind of it did something different. It was parameterized somehow by the implementation. If the method is completely generic, and I would believe that find each has got to be completely generic. It has nothing to do with the structure of these things. In that case, you should be able to just put it in some superclass, just in a regular way, just as a method.
Well, I guess I was wondering if a particular
Oh, so I see what you're saying. So find each, you have to, because it's a class method, you have to stuff it into self,
Right.
and you have to do that at the right time. So you'd have to. Okay, I'd have to actually look at it. I don't know on the top of my head. If put a question and I'll double check. So yeah, put a question. I can't remember the details.
So
Yeah.
the third question.
Yeah.
So when we are creating from the model classes,
Yeah.
When we say DB migrate,
Yeah.
the corresponding tables will be created.
Yes.
But there will be no data in it.
Yes.
So do we, using the CRUD operations, manually enter the data before?
How did I do that? I believe I used that console thing.
Yeah, through the console.
And I think that's what I did. Yes. So, but the assumption that you can have is that when I run your program, that data is there. So you do not have to give me the code to make the data in the database. I will run your program against an already initialized database. But yes, I used the console to enter them. I did not go and laboriously type in things into each of those CRUD screens. I actually have work to do. So.
In the second question, when we link saying has many,
Yeah.
do we get all the 13 methods related to the association? I mean, it's say collection equal to.
No. Why would no? You would not. We're not imitating all of Rails. When you run has many, and
So that would only happen when you are extending active record.
yeah. We're not extending. We're not rebuilding all of active record. We're just rebuilding a tiny portion of it that kind of shows. Yeah. I mean, as I can see from the questions, it does force you through the entire logic path, but it's not going to build the entire thing. So you do not need to add any more than the methods that I asked you to. Yes?
So the class question, extend CSV list, has many choice, belongs to answer, class name choice, and class choice, extend CSV list, what are the statements we have to write here?
N.
And no belongs to.
You don't have to write it belongs to. If you wanted to, you could put the belongs to see that. That's a good second test.
If it makes it complex, we don't want.
No. It's a good test because I might do that. It's a perfect. Your application should handle it whether or not it's in there. If one wants to put it belongs, the important thing to realize is that when one puts the belongs to, it only modifies the class on which it is applied. So when you put the belongs to into question.
Into choice.
Well, let me put first into question. When you put into question, it has no influence whatsoever of what goes on in choice. The choice class is unchanged.
Yes.
If you put the belongs to into choice, it has no impact on the question. It simply adds another field into choice. And you can put it you can put it there, or you can not put it there. And it's a good test to see. First, make it so that you don't put it there. See that regular tests run. Then put it in there, and then you see whether the back relationship gets automatically put in. If it does, that's a powerful signal that you did everything right.
But you will have to put belongs to in choice for answer because there has to be a self.
As it turns out, that the reverse link is accidentally established by the has many. If you think about it, if you look at the data, because the has many requires the back index, and it happens to be the same back index. At least that's what I think. Now, okay, I'll have to think about it. This morning I talked myself into that. Well, now I'd have to look at it. All right, so put more of these questions onto Piazza. If there was some fellow who said, now how can you get an extension? The only way to get an extension is to have a steady stream of really high quality questions on Piazza that show to me that not only is this assignment hard, but you're also progressing on it. Okay? In that case, I'm perfectly willing to say, okay, this is hard and here's why. Otherwise, I just think you're lazy. All right. So let's breeze through this material. I showed you apply at the end of the last lab. So when you have a list of stuff and you want to apply the same function on it, so when you have a list of parameters and you want to apply a function to it, then you use this apply thing. And that happens quite a bit. Let me give you another example that's less imagey. So let's say I have a list of numbers 1, 2, 3. And it's a quoted list because it's those numbers, 1, 2, and 3. And now let's say I want to add them all up. But I already have this in a list. Then my difficulty is that to add, I would have to say plus 1, 2, 3. But how am I going to get these things into this position? And apply solves that. So when I say apply plus, then it makes a new call with this thing as the first argument, and then it splices all of the other entries in here. Do I put a quote to the plus or no? No. Because what I want is I want the actual function, and plus is the function. All right. Now, eval goes one step further. Eval can take any old list. So here I'm taking the list that's consisting of the literal symbol plus, the character, not the function. then and there's 3 and 4, and so far it's just a list. It's not evaluated because of the quote. If I want to evaluate it later, then I can pass that list to eval, and it evaluates it. So it's its own interpreter. So eval you can think of as it's the scheme interpreter. Yeah.
Is this like defining a function?
No.
It seems something like that
Because it's evaluating function. Plus has already been defined. So we're not defining it. It is, I guess the equivalent would be, imagine that you had a string in Java that's a bunch of Java code. So let's say you have the string math.square-root-of-4 as a string of 12 characters. Not as Java code, but as an actual string. Now how do you evaluate it? In Java, this would be genuinely difficult. How would you do this? You would have to write some code, run it through the compiler, and then execute it. You could do this, right? You could, make write it into a file, surround it with a bunch of stuff, compile the file by shelling out and running the compiler, running the file by loading the class. But you wouldn't want to do this. But you could, right? In Scheme, it's the same thing. Now, if I have the quoted list square root of 4, which just is a collection of a string and a number, it's just a list of a string and a number. If I want to evaluate it, I just call eval.
If you just put a string there as in hello instead of
so if I just say eval square root of 4,
yeah, that would evaluate that, right? But instead of
no, what would this, no. Let's look at this. What would this do? Okay, but what if I use the quotes? What do you think it'll do?
So print it.
No, it'll just return it to me.
Yeah, it will return a string.
yeah.
Because a string evaluates to itself. An expression evaluates to something different, but like eval of 42 is 42, but eval of a plus will evaluate to something. So the beauty of this is that you can generate arbitrary code on the fly and execute it later. So you can write programs that write a program and execute it later. So I'm doing this here by coming up with a strange way of evaluating factorial. Oops, I forgot I can do this. So let's say I have a function that I call range that I'm just defining to you in case you want to try this out at home. Range is a function that gives me the numbers from 1 to n. So when I say range 1, 10, then it just gives me the list 1, 2, up to 10. So, and I wrote that here. Trust me, that works. Now I'm going to show you a way of writing factorial that uses either apply or that uses eval. So with apply, it's actually very simple. I say apply the asterisk operator on this range. And that means it's just going to put the asterisk here and evaluate that whole thing. That's a nicer way of doing it than to do than to actually write a loop or a recursion, right? And it's just very natural because it just happens that it can generate the parameters in this way. Now let's look at what happens with the eval here. So here I'm making a list that starts out with not the multiplication function, but the multiplication symbol. That's why I quoted it. And then afterwards, with the cons, remember the cons, it takes the start of a list, and then it takes the tail. And now what it is, it's a list. It's a list with 11 elements that by itself just stands for itself. But now I call eval on it. And when you call eval on it, then it says, oh, this thing, I'm going to look up what this thing is. It's the multiplication function. Then it's going to apply. So this one here actually first computes the code for the function, and then it executes the function. So that's not a very it's a very odd way of doing it. So, as it turns out, you can define the eval function in Scheme. So you can write in Scheme the code for eval. And so when one looks at this book, this famous book by Abelson and Sussman, they do that. They give you a complete definition of eval. It's kind of longish, and we'll go through bits and pieces of it. So the reason is that a Scheme program is a list. So you can write a function that consumes a list and evaluates it, and you can write it in the very same language that you're using. So it's called meta-circular because you're writing a function in Scheme that can find the meaning of any Scheme program. And so why do people do that? In this Wizard book, they do that to study the implementation of various language dialects on where they tweak different things in the language. We're not going to be doing that here. But it's a very interesting book. So if you have a half a year of free time, you should by all means go and work through the entire thing. So it turns out that eval and apply kind of use each other. And so they have this yin and yang diagram in the book where they say the job of eval is to deal with functions and arguments, and the job of apply is to deal with expressions and environment. Environment is another way of saying a symbol table, something that contains bindings of names to values. And so when you call eval, it takes an expression, and the eval that you've just seen evaluates in the global environment, but it turns out to be better to write eval so that it can take any environment. So environment, again, is a binding of names to values. And so eval now wants to evaluate this expression in this given binding. So for example, if I evaluate, say, the expression f a in some environment, then I have to look up what does f actually mean. And so this environment is going to be a list of pairs where it says f is a lambda something, a is 42, x is minus 1, and so on. So that's what an environment is. So it's going to look up what the various things are. Now, then once it has found what f is, then it sees that f is a lambda. So what is a lambda? So f is going to look like a lambda x, and then inside here it's going to be some expression that has x's inside. And then what do you have to do? You have to go through this thing here, and wherever you find the x, you have to put in 42, because that was the binding for a. So you have to make that kind of substitution. That substitution you can make in a completely formal way. The other way you can do it, and that's the way that the interpreter actually does it, is they say it's tedious to go through there and replace every x by 42. What they instead do is say, well, we can simply now take this expression here, and we're going to evaluate it in an environment in which x is 42. When we add this binding to it and do the evaluation in that environment, then every time x is looked up, it's going to have this right value. So what that points to is that eval needs apply, because eval is going to apply a function to an argument. Apply needs eval so that it can apply that can evaluate the function binding. So this all looks very abstract, and I have the perfect way, as you'll see shortly, to make this more real. I'm going to make you implement it. So it turns out that if we strip down the thing a little bit, we can do it shorter. Then here's the definition from Abelson and Sussman, and you can see, it goes through a lot of detail. But we're going to have a homework where I'm stripping down Scheme to its most basic things, and you're going to be implementing eval and apply in that much more basic setup. So why do people care? And so people like to study programs that can interpret themselves because it lets you reason about some things that are not possible to do. So I don't know if everyone saw this in their undergraduate education, but I kind of hope so. But just in case you didn't. So the Turing's halting problem says that you can't write a program that checks whether a program will terminate on all inputs. Now you might say, why does someone care? But I actually kind of care. The program that I always want is something that can take the student's code and grade it automatically. So I want the program that takes, let's say, your scheme program, because scheme is nice and simple, that takes your scheme program, and that before I even want to run it, I want to make sure that it terminates, right? Because I don't want to waste my time waiting a day or a month or a year maybe for an answer for your program. So could I write a program that takes your program and says it'll always terminate? That would be a desirable property to check. It turns out, and I'll show you in a minute, the answer is no. And it turns out that the answer to almost every one of the similar questions is also no. The other program that I want to write, and I wish I could just raise venture capital to do this, is I have a solution for the program. You're going to give me one. I want to write a program that sucks in both mine and yours and says whether they compute the same thing. That would be great, right? I have my sample solution, I have your solution, and it just says, yes, on all inputs they provide the same output, or no, on some input they provide the wrong output. And so that would be something I could save myself a lot of grading time. I wouldn't actually have to look at your crappy code, right? I could just say, as long as it's the same thing, why do I care otherwise? I could go and sell this to other professors who could use that time to play with the kids or do whatever they want to do. And so I should raise venture capital and start building a website and doing all of this, except that the Turing has proven that you can't write such a program. So I would have to hide that fact from the venture capitalists. And maybe they remember their theory of computation. So in this case, it's very simple to see why such a program can't be written. So let's say that we can write a program that takes a program, which in this case is just a function, and checks whether this function halts on all inputs. So the beauty, again, of formulating this in scheme is that this thing here it's very obvious that this thing is a function, right? This is what a function looks like in scheme. And it's obvious that it's got to be possible to process this thing in scheme, because you can take this apart. This is the first, this is the rest, this is the this is the rest of the rest, and you can look at these things and see what's going on the side there. So it should be possible to explore this. So we want this thing to return true if this expression halts for all inputs. Now let's say that I had such a thing, and then I can make a different function, and let's just bind it to k, and here's my function. It takes an x, and it has a bunch of code in it. So, and what's that code? The code is a little bit bizarre. Inside here, I'm coding up an infinite loop. This is a loop function that when you call it, it calls the loop function, which calls the loop function, which calls the loop function. This is an infinite loop. So if the halt checker says, yes, whatever x was a piece of code, if x will always halt, I'm going to run it myself in an infinite loop. Otherwise, I'm going to return true. And now you ask yourself, what happens if I take this thing that I call k and have k evaluate itself? And at this point, you're going to get a contradiction. Because suppose k halts. So let's see, but what does k actually do? K says x is k, so halt checker of k means it always halts. But then it gets an infinite loop. But we just say it always halts, so that can't be right. So obviously this thing can't return true. So it must get itself in an infinite loop. But let's say it gets itself in an infinite loop. If we explore this, then we say, then the halt checker must return false, because it got itself in an infinite loop with at least one input, namely k. But then it must return true, which is exactly the opposite. So no matter which way you think through it, it turns out that this thing here cannot, it can't work. And so this means that the halt checker cannot be written. So that's a very classic contradiction. And it's, in scheme, it's pretty easy to understand. The way they show it to you in a theory of computation course is with the Turing machine. where a Turing machine can process a Turing machine. And that is, I think, less intuitive to most people why that would be so. But it's very intuitive that a scheme program can consume a scheme program. All right, now macros. So one often wants to write code in Scheme that generates more Scheme code. And so as an example, remember how in Scala we wrote our own while function? Because we could. And so let's try this in Scheme. It's not a hard thing to do. So we would make a, so what we want is we want to have while x is greater than 0, then a keyword do, and then we want to print stuff. So we can do it with closures, but the difficulty is that it looks ugly. So you have a while do that takes a closure for the condition, that takes a closure of the step that I want to do every time. Because every time that you want to pass some functionality into another function in Scheme, you have to give that function as a function. In Scala, I was able to do some trick because there was a way of turning a block into a function with that call by name syntax. They invented some special syntax to not have you see these lambdas. They were there, but you didn't see them. Now, Scheme does not believe in having 200 separate syntactical rules to make tricks like that happen. Scheme is not Ruby or Scala. In Ruby and Scala, one has all of these little nifty shortcuts where you can omit this and omit that, and it all gets put back in, and so you get the illusion of simplicity. Scheme doesn't do that. What you see is what you get. And so instead what they do is they come up with a separate mechanism for inventing your own control structures called macros. Macros are processed before the regular evaluation. So we're going to be defining a while macro in a minute. And when you write this thing into the evaluator, then the macro system kicks in and says, oh, I have a macro definition for while. It's going to take, this after all, it's just a list. It's a list of length, of length 6. It's going to take that list of length 6, rewrite it according to the rules of the macro that you see in a minute into something that then gets evaluated. So you have this 2-layer processing with macros first and then regular evaluations. Just like in what other language? Where else do you have macros that get processed before the compiler kicks in? C. Exactly. Right? In C, you use pound define, and you have these macros. The only difference is that the C macros are infamous for that the C macros don't understand the C language. So you can write macros that create bizarre effects. And the Scheme macros have been carefully designed and refined over the ages that they fit in with the Scheme language, and you can't create those. But that makes them a little bit more complicated. So over here, for example, I have a swap macro. And so you say define syntax, I call it swap. And the syntax for these things is not brilliant. You have to use this thing called syntax rules. There's something that we'll see in a minute. And now I have to put in a pattern that says whenever you see the word swap, the exclamation marks means that we're doing some mutation. That's just a convention. With 2 things, then you want to replace it with this code. And this is the usual swapping code where I have a temporary that I copy A into, I'm setting A to B, I'm setting B to that temporary. So every time it sees this, you want to have this. You can have other patterns here. For example, you could swap 3 variables here in a ring shape. So this thing is called a hygienic macro because suppose we call swap of xc, and notice that c is also here this local variable. At this point, it'll realize that this c and that c can't possibly mean the same thing, and it's going to rename this c on the fly. In that regard, they were different than the macros in C, because in C, if you were to do this, I can do this. What did I use here? A, B. And how do I define it? Oh, I don't even know how can I define. Let's say they're integers. What is it? A equals B. So I can write this macro in C, and it'll work. If I say swap xy, it'll swap x and y. But if I say swap xc, then C will stupidly create the code, you know, what if this is X, what if this is C, then this is C. It'll stupidly say int C equals C. And will it compile? I don't know if it compiles or not, but it'll not get the right result. So the C macros are evil because they don't understand the language, whereas the scheme macros, they understand the possibility of this variable collision, and they will do the right renaming. So actually, when you look at the code that's generated internally, this will not be C, but it'll be, you know, omega 1729 or some variable that doesn't occur anywhere else. So you can, in these macros, you can put keywords. Remember how on this slide I had a somewhat odd syntax, and they do that in these macros, where I have put the word do in here. The word do doesn't do anything. It's just there to make it a little prettier to read. And so if that's your intent, you have to tell the macro system that you're using that keyword for that purpose, so that it doesn't try to evaluate it, that it doesn't try to rename or anything. So, and here's the pattern while condition do. And then over here, we now have a the implementation of while. So let's actually study that because it's a little nasty. So we have to write a recursive function, and we don't really have a lot of tools for this. This let rec is necessary because I'm defining loop, and I'm also using loop in the body, and I have to do it at the same time. Because if I were to just use let, then it would it would first look at what the stuff inside here, and it would not tie it up with the same thing that's here. So let rec ties the two together. Now, the function says if the condition is true, then I want to evaluate the body again, and then I want to evaluate this loop statement, where loop is, you know, the thing over here. All right, so the dot 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 simply means that the do can be followed by as many expressions as you want, and they should all be spliced into here. So if I look at the example where I had it, let's just match up the pieces. So the body dot 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 would become these three statements. And they will get spliced in this spot. So it'll then generate this entire piece of code, and that's what gets evaluated. Why the pound F? My problem is that if takes three parts. It takes the condition, the positive, and the negative. I don't actually want to do anything in the negative, but I have to put something in there. It doesn't matter what I put in there. Whatever. And so I just put that as in it.
We're actually defining a variable called loop in
Yes?
LexRec, and then
Yeah, absolutely. And yeah, so I'm defining a variable called loop. What's the type of loop? It's a function. Excellent. Right, because it's a lambda.
Right.
Of how many parameters?
No.
Of no parameters. Right? It's a function of no parameters that in its what does it do? It executes the body once, and then it calls itself again. Which executes the body once, and it calls itself again. But it only does that actually when the condition is true.
And what is the outside loop?
Oh, that's to kick it off. Because the let only makes the definition of this function. It doesn't yet call it, and then I need to kick it off once so that it calls itself. Good question. So this looks a little ugly because I haven't shown you all of, there's some scheme syntax in which you can make this thing a little bit shorter. So for example, why did I use the let construct here with no parameters? Because I haven't shown you any construction how you can execute more than one statement at a time. And there is such a thing in Scheme. In fact, it's implemented as a macro. You can say begin, statement 1, statement 2, statement 3, or should we say expression? They're all expressions. Expression 1, expression 2, expression 3. And then that executes expression 1, expression 2, and expression 3. But I didn't show you that one before. And begin is actually a macro that evaluates into let. because let is a fundamental construct in the scheme language that I did show you, and if you look at that slide where I showed you what let is, let does have the possibility of having multiple expressions. All right, you can do recursive definitions, and I don't think I'm going to get into it because I don't know if we need it. If you need it, you can look it up on the slide. And so the details of these macros get complex kind of quickly, and I could spend an exciting series of lectures on nothing but how to write macros, but I'm not going to do it. All right, so someone said this lab is hard. Let's see how far we're going to get with this. The first step should be fairly straightforward. So we write, what's the type of poly?
Expression.
Everything's an expression. It's a list, excellent, right? It's a list of how many elements? 3. Lambda,
Yeah.
this list, and the plus, right? So, and so what I want you to do is I want you to compute derivatives of this thing. So how do you compute the derivative of a sum? Does anyone remember?
It's the sum of all the derivatives.
It's the sum of the derivatives, right? How do you compute the derivative of a product?
How do you explain that?
So if you take the derivative of u times v,
U times derivative of v plus v times derivative of u.
thank you. Where d dx is the derivative operation, right? So, and we can do this in scheme because we have the code for these things. The code's just lists, and so you can operate on these lists. All right, and I think that's probably all we're going to get to. Okay, but actually, so I have 2 things, and I don't know which one of them is more interesting. So the second one is where I want you to make a macro. So why don't we do this? You guys get to pick which one you want to do. Each group of 2 gets to pick. You want to do the derivative stuff, or you think it's too tedious, then you can do the macro stuff, which is maybe more mind-blowing, but actually easier. So I'll leave it to you. All right, so we have, what, 25 minutes? Yeah?
What's the difference between let rec and let star?
Between let rec and let star. I have to look it up. Let star simultaneously sets all of them but doesn't allow for recursion, I think. And let rec simultaneously sets them all and allows for recursion.
Okay.
I have to look it up every time. And so as a practical matter, whenever my head hurts, I just use let rec, because let rec does it works harder, but it always does what you want. It just makes everything work in terms of everything else. But it's as we will see when we implement it, it has a little bit of an odd twist in terms of implementation. And so the purists will use let star when it suffices. But I've never been that pure. I just said let rec is there, it might as well do its thing.